Hello, and thanks for tuning into my talk. Be sure to also tune in for our live panel discussion where we can go into more depth on some of these issues. So today my talk is about planning for our place amid rising seas. And as I'm sure you all know, ongoing sea level rise is contributing to more extreme and more frequent coastal flooding, causing shifts in housing markets and investments, and also presenting new challenges for public health. Yet when we read news stories about sea level rise, they're often paired with images of ice sheets and polar bears, making the problem seem distant and hence not really so urgent. So I'm beginning this talk with a more visually confronting image, and one that I feel really speaks to the heart of the issue. The reason that sea level rise is such an urgent issue is because of the impacts it will have on our lives. And to understand that, we as scientists must contextualize the science, both literally and figuratively, by putting humans into the picture, as you can see in this image here, where these people are shown with the amount of sea level rise that's expected within their lifetime at the place that they live. And you can see this has a much stronger impact than just looking at a pretty picture of an ice sheet, because it really speaks to how this is going to impact the space that we live in. So today, my talk focuses on how we as scientists can best communicate and work with communities who are on the front lines, grappling with the very problems that we are studying. And given the amount of time I have with you today, I'm going to focus on three different messages that stem from my personal experience of communicating to public audiences and working with policymakers. Before I jump into that, I just wanted to give a really brief introduction of who I am and what I do for those of you who I don't know. I am a geochemist and a geologist, and I study past climate and sea level change, and a lot of the sea level reconstruction I do is based on using fossil corals to track the position of sea level through time. And that takes me around the globe to tropical islands to try to reconstruct sea level using these fossil reefs, which is not such a bad job, I have to say. But in addition to doing the science, because this is such a societally relevant issue, I really feel a moral and ethical obligation to communicate that science to the public. So in addition to doing the science, I also spend a lot of time doing science communication on my research and also on related issues. And I hope that in watching this talk today, whether you are already involved in science communication or not, I hope this encourages you to think more broadly about how we as a community can do this more effectively. It doesn't mean that you all have to go out and give a TED talk or talk on your local news or national news station. I, in fact, think it would be better if we came up with more creative and varied ways of communicating with audiences, and so that we reach different audiences. And so I hope that this empowers you to think more about how we can better connect with the audiences who need this information that we're studying. So one of the points I make when I talk to public audience is that sea level rise is much more than just an inundation of the landscape. And as you can see in pictures like these, obviously, these are some of the more perhaps visually compelling images of climate change. It's hard to imagine what 2 degrees Celsius is. It's a very abstract thing. But here you can really see what we expect in terms of sea level rise. But there are a whole host of other, kind of a domino effect of other things that we need to think about as we think about solutions towards this problem. So for example, if we build a seawall, that won't prevent saltwater from intruding into freshwater aquifers underneath. So it also gives rise to health issues, lack of storm space for stormwater runoff during intense rainfall events, loss of coastal resources, social inequality that I'm going to speak more about later, and economic impacts as well. And so we really need to be thinking about this whole spectrum of issues and not just inundation of the landscape, which is what a lot of the adaptations tend to focus on. Okay, so this brings me to my first message of 3, and that is that the impacts of sea level rise are not gradual. And the reason I make this point is that a lot of the images that we use in communicating this work and what we understand about the science of sea level rise show graphs that make it look like sea level is rising pretty slowly and pretty gradually, which gives the impression to people on the receiving end that the impacts will also be very gradual. So here you're looking at a graph of sea level rise over the last few decades based on satellite data, where the average rate of sea level rise is a little more than 3 millimeters a year, which sounds like not very much. It's the thickness of 2 pennies stacked together. And so often when I present this, I feel a little bit silly because I can almost tell people in the audience sitting in the back are saying, like my beach house is good. Why do I need to worry about 3 millimeters of sea level rise? Well, while this might seem gradual, the impacts will not be. There are going to be, and that's for a couple different reasons. One is that there will be thresholds in the system that once they get crossed, those impacts will become quite severe, whether or not that's a threshold of, say, elevation. If you have a low-lying landscape and you cross some threshold and all of a sudden a large amount of your landscape is then covered with water, whether it's a threshold of infrastructure, capacity, and failure. So there's thresholds in the system. That's one reason. The other reason is that sea level itself really does not rise gradually. The impact of the warming and the melting of the ice sheets and thermal expansion of water, yes, that's contributing over time, but on top of that, it's a very noisy record, and we'll look at that in a moment. So one thing that falls out of this, kind of a corollary of this message, is that the sea level projection curves that we're using, which are often like the main tool when you go into coastal planners, you say, here, use this to plan how you're going to adapt to this situation, can appear very misleading to a lot of people on the receiving end. So let's look at an example of that. And so this really touches on how we're framing the problem and communicating this to people. Now, I could spend my whole talk talking about this one figure, but I'm going to try to limit my comments in the interest of time. This particular one is taken from the National Climate Assessment that was done a few years ago in the US. Please note that the y-axis is in feet, so that's 8 feet there on the left-hand side for the highest scenario by the year 2100, which is kind of hopefully more of a worst case scenario, all the way down to a linear extrapolation of the satellite record, which is the darkest blue curve on the bottom. So one point I want to make quickly is that often people look at this and focus in on the uncertainty. There are a lot of different curves that are shown here, and it makes it seem like we're totally uncertain about what's going to happen in the future. But I like to flip that on its head and say, in fact, we are very certain that sea level is going to keep rising. All of these curves are going up. And in fact, I don't think the linear one should even be there because we know that the rate of sea level rise is accelerating. So we know that it's going to rise and it's accelerating. And on some fundamental level, that's really all you need to know in order to start taking action, rather than using the uncertainty as an excuse to delay responding to this issue. But what I really want to focus here on today is this issue of how gradual that sea level rise is. So let's pick the red curve, for example. In the year 2050, this projects something close to about 2 feet of sea level rise above present. And while these projections are really useful, the thing is, I can guarantee you that sea level rise is not going to look like any of these curves. So saying 2 feet in the year 2050, so I've talked to people who are architects, say, okay, then I can plan for that. I can be ready for 2 feet in 2050. But in fact, what that means is that we're going to be hit 2 feet with increasing frequency until we're there on average by the year 2050. And that's because we're going to have higher extreme events of sea level as we approach that point. This is what actual sea level data looks like. This is a tide gauge from Virginia Key in Florida from 1996 on the left-hand side to 2020 on the right. And again, this y-axis is in feet, it's not metric. And you can see here, obviously we all know that tides, there's a daily variability. You can also see an annual signal in here where they have higher, like king tides in the fall and lower tides in the spring. And on top of that, you can see some of these extreme events coming through. So there are hurricanes with storm surges. Here's Hurricane Irene in 1999, Hurricane Rita, Wilma, Sandy, which did not make landfall in Florida, but still created a storm surge large enough that you see here. But while sea level has been gradually rising in the background, all of a sudden here, when you get to about 5 years ago, you start seeing king tides, king tide, king tide, king tide, at the same level that previously was only experienced during these hurricane storm surges. Then on top of that, a lot of these hurricanes, if you look at the dates closely, you'll notice right in around September or October, Hurricane Irma came in September of 2017 on top of the king tide and sticks out way up here. You will see that some of these events are already pushing about 2 feet above what is kind of the average of today. So that means we're already getting 2 feet occasionally, and during these king tide seasons more often, and we will start to hit that more and more frequently as we approach the year 2050. So I think a better way of framing this and thinking about it that a lot of people are already doing is looking at the frequency of coastal flooding. So this image here comes from a NOAA report where they're showing the percent increase in the frequency of coastal flooding compared to the year 2000, using data up to the year 2017, so over a 17-year period. So these dark red circles are actually showing places where you have more than 200% increase in frequency of coastal flooding just over that time period. In fact, the frequency of coastal flooding from high tides has doubled in the US in just 30 years. And I think understanding the impacts in this way is much more helpful and helps people to understand that sea level rise is going to happen a lot sooner than most think it will, just by looking at those sea level projection curves. Okay, so the second message that I would like to talk about is how we approach this conversation about sea level rise. And oftentimes, we feel like as educators and as scientists, if we go in and give them the information, if we just give them the facts, that will help them to better prepare for the future. But unfortunately, facts are not enough. And it turns out that whether someone is willing to accept the facts has more to do with their identity and ideology, or what you might think of as tribalism. Katharine Hayhoe has a great YouTube video from her Global Weirding series on this. If you haven't seen it, I highly recommend you Google it and find it. This episode is called "If I Just Explain the Facts, They'll Get It," right? The answer is, well, no. Social science tells us that if rejecting the facts is related to our core identity, then arguing over the facts can actually be counterproductive. So people see it as an attack on who they are. So Katharine's advice here is don't start with the science. Connect with people over your shared values. And one thing that I find is very helpful is that communicating is as much about listening, and in fact, perhaps more about listening to other people than it is about telling them. And if you can listen to them, that can lead to a much more productive conversation. And then you can help them connect the dots about how sea level rise or climate change or whatever it is you're talking about will affect the things that they care about and that you both care about together. So you can connect over your shared values. Another example of this in terms of sea level rise is related to this piece that came out in the conversation earlier this year, which was really interesting. And what they were talking about is that there's an online site where there were houses advertised for sale in South Florida, and they were accompanied by this banner ad that had messages such as "flooding hurts home value, know more before you buy, find out free for now." And then if you clicked on that ad, that would provide detailed aerial photos of present and future flooding as a consequence of rising sea level. So some social scientists got really interested in this, and they decided to conduct a survey to find out how this messaging, these ads here, and looking at the maps, was impacting residents' beliefs about climate change and sea level rise. And they also asked if residents believed that their communities and homes were at risk. They found that exposure to the scientific maps, that is seeing these maps and that information, did not influence beliefs that their own homes were susceptible to flooding or that sea level rise would reduce local property values. In other words, it also consistent with national surveys on climate change, they found that political party identification was the strongest predictor of general perceptions of climate change and sea level rise here. So this is yet another example of how giving the facts may not be enough, but it may actually have a negative effect. The strongest negative responses came from Republicans who responded to this survey. And so we need to be thinking perhaps more creatively about how we communicate this information and engage with these communities. Okay, third message is that oftentimes you hear, well, okay, sea level rise is an issue, we'll admit that, but we can just adapt, right? We can just engineer our way out of this thing. And I think this is entirely the wrong approach for several reasons. Here's an example. This article was published last year. The Army Corps of Engineers had just finished building these new levees after a $14 billion upgrade. And last year when this article was published, these levees were only 4 years away from becoming inadequate to rising sea levels. So in the first instance, you need to plan for future sea level rise when you're investing in infrastructure. But look at the price tag on this. We are just not going to be able to afford this. And there's also a question of whether or not we want to do this. Do we want to be building walls around our entire coastline and living in a bowl the way they are in New Orleans? Because we can see how that plays out when those walls get breached. Here's an example from Sugarloaf Key, Florida. From a few months ago, they released a study that they did to see how much it would cost to raise a stretch of road, a single 3-mile stretch of road at the southern tip of this key, which is a little bit north of Key West, so that they could keep it dry year round. And so they estimated that to keep it dry up into the year 2025 would require raising it by about 1.3 feet using some local sea level projections at a cost of $75 million. And you can see how that cost blows out up to 2060. It would cost $181 million just to keep this 1 3-mile stretch of road dry. And now, mind you, the water that was sitting on the road, if you raise the road, is now going to be sitting in the front yards of the houses next to the road. So it will make flooding worse for them. So this is clearly not going to be a solution. And it was one of the first times that public officials actually had to confess that, look, as sea levels rise and flooding gets worse, not everyone can be saved. It's just going to be too expensive. And so we can't take this approach of saying we're going to just defend our coastline where it is when we know that over time that coastline is going to be retreating. And ultimately, in the long term, there's really two choices. You can build a wall and live in a bowl, or you can retreat. And that's kind of the mindset I think we need to be approaching this with. On the subject of engineering things and seawalls is that, and perhaps some of my colleagues won't be so happy with me saying this, but I'm not a huge fan of seawalls. And it's really the first knee-jerk reaction that most communities have who are starting to experience more extreme and frequent coastal flooding. One of those reasons has to do with environmental justice, is that this really exacerbates existing racial and social inequality. The communities that can put in seawalls are those that can afford it. And again, the water that would have been there is now displaced and pushed off to the communities who cannot afford it, making the flooding even worse for them. A recent analysis by E&E News of federal flood insurance in the US showed that flooding disproportionately harms African American neighborhoods, in part because many of those neighborhoods are in lower lying areas. And that study, I should say, includes both inland flooding as well as coastal flooding. And so this is, in my mind, not a great solution. And also seawalls obviously also increase erosion on the seaward side. And at some point, that wall will get breached or it will fail. And so having the wall there in the first place really builds in a false sense of complacency for the people who are living behind that wall, because then they are all the more vulnerable to that damage, that sudden damage when that wall does fail, because they thought they were safe sitting behind that wall. Okay, so these three messages, in a way, touched on a lot of things that I feel like we can do better in terms of communicating, but I want to talk a little more about solutions and future directions. One of those is that we really need to acknowledge the emotional landscape when we have these conversations with people. I made this point before about listening being an important part of communicating, but also acknowledging the grief that everyone in coastal communities around the globe is going to be going through when understanding that coastal retreat is going to happen, whether we like it or not. And we need to address that and acknowledge it before we can really get to the point of having everyone accept it and do something about it. The other point I want to make is that we need to be more proactive about having a more diverse and inclusive group of people communicating and also people that we are talking to. And this is really important for many reasons. It will improve the communication. It will improve our ability to connect with audiences who need to hear the message. And I feel like this is an area that we really need to work on a bit more. Finally, I hope that in listening to this, you've gotten the message that, in my opinion, I think that science is going to be a really important part of this policy development, and that we as scientists need to not be afraid to engage in that, and at the same time, tap into our humanity in the process, and not just be objective scientists writing research reports and writing papers, but that we engage in this process. Thank you.